not all identical statements, identical looking statements, you have to like you need not approach all these statements in the same manner. One, you can calculate the probability. One, you can use a non-decreasingness to disprove it. You can use some inequalities to get what you want. So there are different ways of attacking the same problem, different ways of attacking same statement, almost similar looking statements.
Hello, guys. Welcome to Chinta's School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So here again we have four statements which were asked to find if they are true or not. Here we are told that the average score of the group can take some value, and on the basis of what value it takes, we have to find the probability that it takes that value, or it's less than that value, or it gets greater than that value. So we're using a fact here that if x is a normal, if x follows a normal distribution with the parameters mu and sigma square, then x bar, which is basically the mean of x, follows another normal distribution with the parameters mu, sigma square by n. So what is this n? N is the number of observations that we have. In our case, it's 225 because we have the information about 225 students. So let's take each of the statements one by one. The first statement says that the probability that the average score of the group is 220 students is less than 48 is 2%. Bit long and bit confusing, so let's shorten it down to this one. Probability of x bar less than 48 is 0.02. So let's take this statement and then do some algebraic manipulation to get this. Subtract the mean, divide by the standard deviation, because we know that this will be a standard normal variant. Now we know mu, we have calculated this to be 15. We know sigma, calculated this to be 15. We know n to be 225, so square root of n is basically 15 again. So sigma by square root of n cancels out to be 1. So this value comes down to be -2. So this thing is nothing but phi of -2, which we know to be 0.02, which is basically what we have claimed. Thus, statement A is correct. Moving on to B, it is that average score less than 42.5, the probability is 6.7%. Okay. So let's rewrite again this in probabilistic terms. So let's just clean this up and let's write it properly. This should be something 0.067. The probability that x bar is less than 42.5 is 0.067. Now, before we move on to this question, first let's understand that this thing is nothing but the CDF of x bar. The CDF should be non-decreasing. One of the properties of a function being a CDF is that it is non-decreasing. Some others being that it is always positive, it is right continuous, and this one is non-decreasing basically. So if the CDF is basically this, f of x bar at x, then it's nothing but probability of x bar less than is equal to x. So it's continuous random variables, less than is equal to and less than really doesn't make any difference, because at the end of the day we are computing an integral. So this is nothing but f of x bar at 42.5. Now this is, since this is non-decreasing, right? So this is non-decreasing. So f of x bar at 42.5 must be at most f of x bar at 48, because it is non-decreasing, right? So if x is less than is equal to y, because this is non-decreasing, if x is less than is equal to y, then I must have fx is equal to f(y), which is non-decreasing. So This is 42.5 and this is 48. So this value should be at most this value, and I know this to be 0.02. So there is no way this can be 0.067, right? There's no way that this can be. This is wrong. So P is false. So this basically contradicts the fact that CDF is not decreasing. That's how I know this is false. Moving on to the third statement, we have that the probability average score is greater than 49 is more than 50%. Let's again write this in probability terms. That is, probability of X bar greater than 49 is 0.5. Again, take its complement. Probability of X bar less than is equal to 49 is less than is equal to 0.5. So let's calculate this value first. Let's calculate this value, and then we will see if it is less than 0.5 or not. So this is nothing but, let's, after doing the algebraic manipulation, it comes out to be -1 here. And I know that phi of -1 is 0.16 from that table, and 0.16 is less than 0.5. So this statement holds true. So C is correct. Going to the last statement, which is the probability that the average score is greater than 57.5 is more than 16%. So it's this probability that X bar is greater than 57.5 is greater than 0.16. Again, take its complement. So probability of X bar less than is equal to 57.5 is less than is equal to 0.84, because basically you're subtracting something, right? You're subtracting 1 minus, you're doing it. So basically the sign changes. So I'm saying that this probability is bounded above by 0.84. Again, so let's basically calculate what this probability is. So it is X bar minus mu by sigma by root n, like basically we are standardizing it. And this side it comes out to be 7.5. So phi of 7.5 is far greater than phi of 2, because again it is not decreasing. Phi of 2 is 0.98. So phi of 7.5 is much greater than 0.98, probably something less than 1. 0.98 is greater than again 0.84. So this probability is greater than 0.84. So this statement doesn't hold. So that means this statement doesn't hold. So D is false. So what we have seen here is that this holds, this holds, this doesn't, and this doesn't. So another key takeaway from this statement is that not all identical statements, identical looking statements, you have to like you need not approach all these statements in the same manner. One, you can calculate the probability. One, you can use a non-decreasingness to disprove it. You can use some inequalities to get what you want. So there are different ways of attacking the same problem, different ways of attacking same statement, almost similar looking statements. So these were two very interesting problems that I wanted to bring to you. So thank you for watching. I'll see you in the video. Goodbye.
To book a trial class for your preparation courses of IITJM MS, ISIM STAT and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.